Welcome to GriidAi. In this chat session, we'll try to explore the potential of GriidAi in mapping the different deforestation zones that we have for the Sentinel global data. So let us create a new chat session. And let us upload the TIFF data too for the different time periods. We are having it for 1992 to 2022. So as the file size was very small, it got uploaded very fast. So now let us start the analysis for that. So basically, let us assess the differences between these two time periods and see how the deforestation has happened in this area. So in order to do that, we first of all project it to the same coordinate system and ensure that both of the data is in the same, as we will be calculating the areas and other properties of these classes. So let us do that. So now once I give the prompt, it has understood the prompt and it is giving it clarity to me. And once the prompt is very clear and it is able to understand everything, it automatically proceeds for the execution. And if it is having any confusions or minor clarification is required, then it would wait for our clarification and then it would initiate the processing. Basically, this data set, if you see, the classes are given by binary numbers and the pixel values are classified and indexed with those numbers. So these numbers that it is going to calculate, yeah, now we can see it is having the unique land cover values like 10, 11, 30, 40, 50. These are all the index numbers that is representing a certain classifications done in the land use and land cover things. However, the data is not having those information. It is we are bound to give that what sort of a class it is. So it will be asking for that in the coming stages. So yeah, it has assessed and it is clearly giving that the CRS and everything is correct, that the cell size is correctly working out, and the pixel area is 300 square meters resolution. So yeah, so now let us proceed for the next analysis where we will ask the percentage changes between these two time periods and see in which classes the major percentage of changes is being observed. Of course, as we have the index informations on these different classes, we need not worry at the very early stages. Uh, However, it is asking it right now, I think. Okay, so it is asking what is the class index is. So we have the detailed informations on that. Probably if we go to the website, we can have all the metadata informations of the ESA global land cover data. So the same thing, I have kept it ready in order to save the time in this recording session. So as I given these details, now it will take up these details and it will start calculating the percentages for us. Yeah, so now it has given the plan. It is taking these two rasters and it is going to cluster code name and all those things it is going to do it. And It's going to give a CSV table file also. Yeah, now if you see in the file data catalog, it has created the CSV file, and we can see the table too. Yeah, so it has shown in 1992 what was the cropland area square kilometers and how much it has changed in 2022. So it has more or less 100 percentage, double the time it has increased. So all those metrics are calculated and kept ready for us. So next is, let us do a specific categorical analysis. Basically, here we are trying to see the transition matrix. So from which category to which category it has shifted. Land use, land cover has changed over the period of 1992 to 2022. So it's giving the plan. Yeah. So that is what it is trying to take confirmation from us. So now if you see, you can even observe the percentage of the process that is being completed here. So that is also advantageous, whether the process is being done and slightly working. And just in case, due to some technical issues or connections between the systems, if it fails, it reiterates and it extracts the data and it shows it clear. So of course, at the first space itself, it got processed and it has given a clear indication how much area has been changed and from where to where it has changed. So the transition matrix is here available with us. Now the last thing that we need to do is we'll ask it to give a summary report where it has changed from closed to open canopy forest class. Basically, we are trying to specifically try to take out the data for which time period it has changed and get us a report on that. And probably we'll try to export the layer also, the regions where it has changed. so that it is easy for us to have a clarity. So yeah, it has given to crop rain-fed areas, it has changed around 414.36 per kilometers. So these are the top three land cover replacing the forest. So from forest it has changed to shrubland and herbaceous cover and mosaic croplands. These are the different classes which has been changed from forest region. And now let us try to take it out for a specific area. So now we are trying to identify the regions where the forest was lost and mark those regions with the red color so that we can easily visually see the map also. I think we again need to give the index classifications for this. So let us provide these details. So now wherever the forest region has been converted to the cropland, it will be highlighted in a red color, and other regions will be marked as a regions where the forest has changed to other non-cropland land use land cover. It will be marked in other colors, probably yellow or some other lighter tone. So let us see how it proceeds. So it has given the JSON file code also, as well as it has created the loss raster extent also. Now let us visualize that actually. Yeah. So now wherever you are seeing the red color pixels, it has been changed to the cropland, and the pixels in the yellow color, it's basically from the forest to other non-cropland land use land cover. It has been transitioned. So in this way, we are able to carry out the deforestation analysis if we have the required basic two maps, which is having all these classification details, land use land cover details. Then it's a matter of 5 to 10 minutes. We can easily achieve Right? And of course, this is for an experiment. We have done it in a small extent. With our computation, we can scale it up for a state, bigger regional level. We can do it. So it's all the matter of through the prompts, and we are able to achieve all the results and analysis. In fact, all the insights is also ready for us. Whereas if we have been doing it in the software, creating that insight is also a time-consuming process, and it needs a technical knowledge. But whereas the code is being written by the platform, and it is executing, and it is giving the final insights to us. So that's a time saving as well as an easy hand-on feature for us. So that's the potential of the GriidAi, and we have witnessed it in deforestation analysis. And another experiment we have done it that is on sea level rise, which is a little bit more complex. But GriidAI has been able to execute all those complex analysis in that too. So that's the potential of the platform.